Shall we start, students? Take the study material. Take the study material and keep a notebook by your side, notebook and pen, because it is going to be some programming. So if you are having doubts, you have to write it at the side and keep. So yesterday there was a request for assembly language programming flowchart. So the programs which are very frequently asked, that we will discuss. So let us start with addition of two 8-bit numbers. Now there are two things in this, in the addition of two 8-bit numbers. One for which the sum is 8 bits, another for which the sum will be 16 bits. So in the question, if they are not asking you specifically, like if they are asking you write a program to add two 8-bit numbers, then go by the easy way. Don't go for a sum which is 16 bits. Now, if you are very good at programming, it is your choice that you can decide for yourself. But if you are not so perfect, then you can assume the sum to be 8 bits itself. Because if you are going for 16-bit sum, then one or two instructions will be different. Yes?
Hello?
Yes, speak. Please speak.
Madam, the subject pair, page number, madam.
This is very surprising. It is micro memory devices and microprocessor, and refer to page number 119.
Paper number, madam, paper number.
7.
7119, madam.
Yes, page number 119, paper 7.
Okay, thank you, madam.
So since one program will definitely come, that is why I think somebody has requested yesterday. So take a pen and notebook also. Although everything is there in your material, but still we are discussing about the programs. Like the programs are very clearly given in that particular unit. So one more thing, it is a suggestion from my side. Like if you are going to touch the programs, you should know very well how the instruction is working on the data. Understand the question properly and see how much you can understand and reproduce. See, if it is a theory, then there is a possibility like you can add something. But when it comes to program, these are very, very specific. Each instruction will work in its own way, how it is designed to work. There is nothing like we can change anything there. Right? Okay. So initially we will see the easiest one. It is addition of two 8-bit numbers and the sum is also 8-bit. See, naturally, if I say 2 plus 3 in the decimal number system, it will be 5. And if I say something like 87 plus 23, then your sum will exceed more than 2 digits. I hope you see, if you are having doubts, please unmute yourself and you can ask. You try to understand as much as possible in this class, because I will be assuming that you are understanding. And actually programming is not a class to be taken online, but now the circumstances are unavoidable for us. So if you are taking smaller numbers, the sum also will be within those 2 digits. If the numbers are large, then the sum will exceed 2 digits. It may extend to 3 digits. So with that intention only, the addition of two 8-bit numbers whose sum is 8-bit or whose sum is 16-bit. So anything more than 8-bit, if it is 9 bits also, it will be taken as 16 bits only, because each location will save 8 bits. So you may get a doubt, what about the other bits? Other bits will be padded with 0. That machine will do. You don't have to do anything. The machine will take those other digits as equal to 0 and it will give that number. Right. So now turn to page number 120. I think it is the same number in your material also. Now, if you know anything, you can also tell in spite of me only just telling. So now see, in your program, what is done is the data is given in the memory location in this program. The memory location is 2501. You can see there, data is given as the heading. 2501 is the memory location address in which the data 49H is saved. And a memory location 2502, next memory location, data 56H, H represents hexadecimal, 56 is stored. So the numbers are stored in two memory locations. Now, there are two ways how you can write this addition of two 8-bit numbers. One way is by taking the data in the memory location. And it is not necessary that you have to give location address as 2501. You can also give 2000 or 3000, something like this, or 6000, 5000, anything like this you can give. Only thing is the address bus is 16-bit. So you have to take there something like 2000, 3000, so on. So first I will explain what is there in your textbook. Then I will tell you the other method also. Now first instruction LXI H, 2501. There in the comments you can see it is written as, see why I am referring your own material is, it will be easy for you to read afterwards also. So LXI H 2501 or whatever address you decide to take, 2000, 3000, you can say LXI H 2000 also. Means what it will do, first you have to load the address of the memory location in your program. Without giving the address, it will not know from where it has to take the data. So that is why you have to load the address. Now address is 16-bit. Your H and L registers, they are only 8-bit. So that is why you have to take HL pair. H register is 8-bit, L register is 8-bit. So since the address is 16-bit, you have to take LXI H and that 2501. Then only it will save the 16-bit address in H and L register. Lower bytes will go to L register, higher bytes will go to the H register. Are you understanding? Now, after we have loaded the address, next instruction is move A, M. It means that transfer the data from the memory location whose address is in HL pair to the accumulator. The meaning of that instruction move A, M is data transfer. Move A, M is a data transfer instruction. So it has to transfer the data from the memory location whose address is in HL pair to the accumulator. So like this, accumulator will get the first number for which the addition has to be done. So in the accumulator now, you will have 49H or 49. Next, INX H. INX H means increment the HL pair. It is increment the HL pair. Now, if you say INR H, it means that the contents of H register will only be incremented. But here, your address is in HL pair. You want a pair of register. So from 2501, it should become 2502 because the second data is kept in the memory location whose address is 2502. So instead of saying again LXIH 2502, we are saying simply INXH. Now, why you cannot use LXIH and 2502 is that instruction will be 3-byte instruction, whereas INXH, the purpose of both the instructions is same, but LXIH comma address location is a 3-byte instruction. It will take more machine cycles, whereas INXH, it will take only one, it is only 1-byte instruction. So it will take less machine cycles. So that is why a programmer's efficiency lies in writing a program for the same task which takes less execution time. The efficiency of the programmer lies in seeing that for the same task, the program execution time should be minimum. That is all we all want. Whether we are an intellectual or an illiterate, every time the purpose of the any application will be the same. Only thing is, we always want things to be faster. So that is why only here you have to take care. See, even if you write LXIH once again, it is not wrong. It will be correct only. You will get marks for that also. Don't worry. Because here you are not doing a programmer job. But I only want to tell you that the efficiency lies in seeing that the program takes less execution time. So now, INXH, when you say the HL pair, the contents of HL pair will be incremented by 1. If you write that instruction 2 times means 2 times it will get incremented. So now we want only the second data which is to be taken into the register. Then only the arithmetic logic unit will execute the addition. So now when you say INXH, the HL pair will change from 2501 to 2502. You can write on the paper by your side also. Now put HL and then you write there 2502. Now next what will happen? Next instruction is add M. When you say add M, the contents of memory location, now which memory location? Whose address is in HL pair? Now the HL pair is having 2502 address location. So whatever is there in 2502 location, so as per the data which is given, the data is 56. Now 56 which is present in the memory location, whose address is in HL pair, will be added to the contents of accumulator. So when you say add M, the syntax says that the contents of memory location and the contents of accumulator are added. So first number, when you say move A comma M, has come in the accumulator. Second time when you say INXH, the second number is present in the memory location. And when you say add M, it will take directly the data from that location and it will add it to the contents of accumulator. And after addition, the results will be in accumulator only. The result will be in the accumulator register only. For all the arithmetic and logical operations in all the processors, the result will always be in the accumulator. So now if you want, you can check directly the contents of accumulator, which you must have also seen in your practicals, or you can move the contents of accumulator to a memory location and check the location for the answer. So if you want to move the contents of accumulator to the memory location, then you have to give an instruction like STA, store contents of accumulator. STA, where it has to store? To a memory location whose address is 2503H. Here again, see, once again you can say LXIH 2503, and once again you can say move M, A. Here it will change. Earlier we have moved from memory location to accumulator. Now you want to move from accumulator to memory location. So now the data transfer instruction will be, see, first you have to, in this case, move M, A you have to give. Then only it will move the contents of accumulator to memory location whose address is in HL pair. So this is how the program which is given in your material will work. And the comments which are given there, if you know how the instruction is working, with that comments, you can very easily understand how each instruction is working there. And then finally, halt is given to say that it is the end of the program. Now, if the data and the result both are given in memory location, then this program will work. The simplest program I will tell you is only 3 instructions. See there, you can write on your notebook also. MVIA, comma 49H. MVIA, comma 49H. Then next instruction. Now again see, there are 2-3 ways in which you can execute this program. I'll tell you all the 3 different ways which it is possible. You wrote first one MVIA, comma 49H. Then you can say move MVIB, or you can say C, H, L, D, E. All these are general purpose registers. B, C, D, E, H, L. Forget that HL is having memory location. This is another program for the same purpose. MVIA, comma 49H. Then you can say MVIB, comma 56H. Then you can say add B. When you say add B, it will add the contents of B register to the contents of A register. So whatever is there in A register and B registers, it will simply add. And the result will be in the accumulator. Then you can say halt, HLT. So in this program, you had 4 instructions. Halt is anyway, it is an indication that it will stop. So you have loaded accumulator with one 8-bit data. You have loaded the B register with another 8-bit data, and you have given the instruction add B. With that, you are doing the addition. Otherwise, there is another way. Instead of saying MVIB, comma data, you can also say add immediate 56. So when you say add immediate 56, it will directly add 56 with the contents of accumulator and save the result in the accumulator. Only 2 instructions. MVIA, comma 49, ADI 56. So whenever I is coming in the instruction, it means the operand is their data. This is what you have to understand. And then naturally you have to say halt. So this is how there are 3 different ways in which the same program can be written and executed. Is it okay?
Ma'am, in the examination, we had to written only as like this MVIA, comma 49. Only 3 to 4 steps we have to write. That much enough, ma'am. Our mission codes, mnemonic, operands, comments,
No.
that all right.
Yeah, don't write. See there in the program which is given in your material also, you can see there memory address wherever you want, you can start. But see that if the data is also in the memory, same memory location you cannot use for data as well as for the program. So data is initially stored, and then the program you will write, and then you will when you are loading, no, you must have done in the lab also. So when you are trying to give the starting address, you will give memory substitute.
Yes, ma'am.
And you will give 3000, 2000, and then from that location you will start entering the mnemonics and the opcode. So in the exam, see, if you are writing memory address, for each instruction you should know whether it is 1 byte, 2 byte, 3 byte, because you see the material itself, LXI H, 2501. In that, if you see the machine codes, there are 3 machine codes for that instruction.
Yes,
That
ma'am.
machine code will depend upon the number of bytes of the instruction. LXI
That mission codes are displayed in the mission only. How can we write?
No, you don't have to write the machine codes in the exam, because
Okay,
for that they have to supply that chart for you. That supply of chart is not allowed in the exam. So you should not write the machine code. What you have to write is memory address you have to write, mnemonics you have to write, operands you have to write, as well as the comments. So
Okay,
leaving machine code, the other things which are there in the table you can write. Comments also, whatever you know you will write. If you don't know, you can leave. It is not compulsory that you have to write the comments. If you are writing, it gives an impression that you know very well how the instructions are working. It only reflects your knowledge.
Yes, ma'am.
And naturally, as most of you also know, we are all impressed by the way the answers will be. And naturally, that also fetches more marks. Is it not? Writing counts, the way the answer is written, that also counts. Further, the important points which are mentioned in your answer. See, if the answer is for 2 pages and the same thing is being repeated, anybody can make out what it reflects about the person. So all these points I need not tell, you are quite grown up people. So leave machine codes, don't worry about them, but the flow of the program should be clear. And please remember that any program, it is not necessary that whatever is there in your textbook, that only you have to write. No, any program can be written in 2-3 ways. The only thing is how you attain the final answer. So for that, you can use very intelligently the instructions. And the 10 instructions can be compressed into 3 or 4 also. But the purpose is solved. What is the aim of that program? If you get the result in a proper logical way, it is enough for you. Right? So now we have seen the sum of two 8-bit numbers is also an 8-bit number. For that we have seen. Now what happens if the sum is exceeding 8 bits? How that program will be different? See, in the question paper, again I am telling, unless they are saying whose sum is 16-bit or 8-bit, don't go into complications. Try to take the easy path. It will make your work simple. We want marks. So go by an easy way, such that it will fetch you mark, and you will also not have that load of writing the exam or answering that question. Now let us see for the 16-bit sum. Now immediately next program only is on page number 121. It is in all the programs I have seen in the material, they have taken data in memory location and the result is also displayed in the memory location. For small programs, directly you can use general purpose registers and finish the job. Right? I don't know, addition program you must have done in the lab also. So which way you have taken, that you only know. Now next, for the 16-bit, how the program changes, let us see here. See LXIH, that instruction is same because the data is given in the memory location. So you are loading the HL pair. LXI it is. See there, again I is coming. It is immediate addressing mode. So directly the address is given in the HL pair. Now see here, one more thing or point which you have to remember here is, it is not necessary that always whatever is there in HL pair should be an address location. It can also be a 16-bit data. If you want to add two 16-bit numbers, now we are adding only 8-bit numbers. If you want to add two 16-bit numbers, in such a situation, LXIH 2501H will become a data, 16-bit data. In this program, it is an address, right? I hope I am not confusing you people.
Yes, ma'am.
Yes, in this program, it is an address. It is not necessary that it should always be an address. It could also be a 16-bit data. So now next you see, next instruction is MVIC, 00. When you give such an instruction, MVIC, 00 means you are clearing that register if by default or by mistake any data is present, it will be cleared when you say MVIC, 00. You have cleared the C register. Why we need the C register? That you will see little later. So now next is from the memory location, you have to get a data, because all arithmetic and logical operations, whether you are saying A plus B or A minus B, or you are saying, or you are taking the logical operations, or you are trying to complement the contents of accumulator. So all such instructions, one data should always be in the accumulator. So that is why now first you have to move one data into accumulator. So for that you will say move A comma M, means whatever are the contents in the memory location whose address is in HL pair, from where it has to take, always it will take, see this instruction, whenever M appears, it means it has to take the data from an address location whose address is in HL pair. For 8085, this is standard. So you will always have the, it is designed like that only. So you have to take it like that only. So from the memory location 2501, whatever data is there, in the next program 2501 is having 98H as the data, that will be shifted into accumulator register. Now next, again INXH means it will increment the contents of register pair HL. Since you have loaded the address in HL pair, you are saying INXH. INXD is also there. INXB is also there. But for our program, we want H only because the address is in HL pair only. So INXH, it will increment the contents of HL pair. It will become 2502. Now in 2502, we have saved another 8-bit data, that is 9A. So now for that, you have to give an instruction add M. Means it will understand that it has to take the second 8-bit data from the memory location whose address is in HL pair, and it will add it to the contents of accumulator, where already we have brought the first 8-bit data. Now see the next instruction, that is interesting. Jump if no carry to ahead. Now yesterday also I referred this point. Arithmetic and logical operations will change the status of the flag. So now this addition instruction will change all the flags. So if by the addition there is a carry, the carry flag will be reflecting that. It will be set. If there is a carry, it will set the carry flag. So once the carry flag is set, how do you know? That is inside. You will not know. So for that, you have to give an instruction saying that jump if no carry to head. If there is a carry, you increment C. C register, we cleared it and kept. so that if there is a carry in the flag register, you can simply say there increment C. Now the branching instruction has to take a decision by checking the carry flag, that you don't have to do anything. The program will do if you write the instruction. Now we don't know whether there is a carry or no. So what? After the add instruction, carry flag will change its status. So whether there is a carry or no carry, if there is a carry, you increment C register. If there is no carry, move the contents of accumulator to a memory location. There are two things. A decision has to be taken by JNC ahead instruction. If there is a carry, it has to increment the contents of C register. C register, we cleared it and kept. So now if it is incrementing, it will increment by 1 if there is a carry. If there is no carry, it will leave that instruction. It will skip that instruction and go to STA 2503. Means it will store the result in the accumulator to a memory location whose address is 2503H. So if there is a carry, C register is incremented. Once the C register is incremented, you are moving the contents. After moving the result in accumulator, you are also moving the carry into the accumulator, and from the accumulator it will move to the memory location 2504. This is what that program will do. So unless it is mentioned in the question, don't go for 16-bit result of addition. Right?
Yes, ma'am.
Is it okay with you?
Yes, ma'am.
See, whatever change is there in the flag register, you can check accumulator. You must have seen in your practical lab also. If you simply press A key on that processor, it will show whatever is there in the accumulator. Similarly, if you press the B register, it will register. There is some register check one command will be there, and directly you can check it when you press that particular key. So it will show directly the result. But flags you cannot check like that. So for the flags, you have to give a branching instruction. That instruction will check whether the carry is 0 or it is 1. And if it is 0, it has to take one path. If it is 1, then it has to take another path. That is how every time a branching instruction will work. If the condition is satisfied, then it has to execute one instruction. If the condition is not satisfied, then it has to take another instruction. This is how it works. Now, next one we will see is, I think, subtraction we can see. Subtraction also, just as I said, you can directly load accumulator and then give ADI. Like this, even subtraction also you can simply use a smaller program, directly give the larger number in the accumulator. So see, in the exam, they will not give you data. Whatever data you are choosing, it is your choice. So you can use smaller numbers and the purpose will be solved. Don't go for larger numbers and get into complications. So now in this, the program, it is same like addition. Only one instruction is changing, that is SUBM. Earlier it was addm. Now it is SUBM. You can check. I'll give you 2 minutes time. Check it. Same instructions, only one instruction, that is there you are having add, here you are having subtract.
Yes, ma'am. Same.
So you don't get scared by the programming. If you see what all instructions are used in the program, that you understand thoroughly, that will help you in writing the program. So earlier I said you are having an instruction ADI, you can give data. Similarly, you can also give SBI. Or if you are using only general purpose register, load one data in accumulator, load another data in any other general purpose register, and simply say sub B. So if you can take MVI A comma 49, and then you can take MVI B comma 32, and then you can say sub B. Means it will subtract the contents of B register from the A register. If you are giving instead of ADI for subtraction also you are having SBI. SBI second data you can give, and in 3 instructions your program will be over. Last instruction being HLT. Right? So it is very simple in this way. Now one more thing, next one on page number 123. That is decimal addition. Decimal addition of 2 8-bit numbers.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, in the subtraction,
Yes.
LXIH, MOV A comma M, again INXH, again SUBM, again INXH is there, ma'am.
So see, I told in the addition also, 2 numbers, no? A minus B you have to do.
Yes,
one
ma'am.
number is in one location, that is 2501. Second number is in 2502.
Okay, ma'am.
So you have to give the address location 2502. So that is why you have to say INXH, then only the contents of register pair HL will change from 2501 to 2502.
But
When you
in addition, there is not given, ma'am, INXH after add M. No need, ma'am.
Wait,
In the addition program,
no,
after
without giving,
add M,
they have taken that instruction is
For
given before.
result, they took it seems.
Before only they have given, no, INXH.
Before only given. After add M, they didn't given the instruction.
See here. See, I will tell you what is the difference there. In that and this instruction, there what has happened, see, INXH before SUB, that will change 2501 to 2502. Once again, when you say INXH, it will change from 2502 to 2503. Here INXH is doing that work of changing from 2502 to 2503, whereas in the addition, they will say STA 2503. STA 2503 means whatever is there in accumulator, you push on to the memory location whose address is 2503. The purpose is same. We want the result to go to the location 2503.
To store the result, they took one more memory address.
Yes. Very good. To push, their instructions are changed, but the purpose is same. There they have sent STA, they have given the address location. Here instead of giving STA, they said INXH.
Okay, ma'am. Instead of these two INXH and move M, instead of this, we put STA instruction also.
Yes.
Okay, understand, ma'am.
Now, after saying INXH, what has happened is HL pair is having 2503 in subtraction. And after saying 2503, they have to say move M comma A. There one instruction, STA, is finishing the job for you. But here 2 instructions will do that same work. INX as well as move M comma A. Here 2 instructions they have used. There they have used only 1 instruction.
Okay.
That is the difference between that and this. but the purpose is same. Purpose is whatever result is there in accumulator, you have to push on to the memory location whose address is 2503. So that is how it works. Then next one, decimal addition. So now all the time, see, microprocessor, whichever data you give, it will take it in hexadecimal. Execution also it will do in hexadecimal only. But we want an answer which will be in the decimal number system. So if we want to see the answer in decimal number system, there is one instruction in your instruction set of 8085. DAA. So that will, and you have to use that instruction after add instruction only.
Yes.
Please remember this point. It is probable that they may ask decimal addition also. So that is why go through the program and just see where you are having the doubts. So LXIH, as usual, that same instruction. Then they are clearing the register C. Why it is cleared is if there is any carry, that it should go to the it should go to the C register from the status of the flags. So for that purpose only they have cleared the C register here, and then move the contents from memory location whose address is in HL pair to the accumulator, and then increment H, then add M. After addition, they have 1 minute.
Ma'am, in addition of a 16 8-bit number, we used MVI, ma'am. In subtraction, why we want to use MVI, ma'am?
Yes, could you please repeat what you said just now?
In addition of 2 8-bit, ma'am, we used MVIC, 00, but in subtraction, we won't use, ma'am.
You can say MVI A, one data should be in accumulator. You can use that instruction. Directly you can take the data to accumulator. Then
Here,
you can,
I means the immediate data we can store in that, ma'am.
yes, accumulator can take 8-bit immediate data, means you don't have to give in the memory location 2501. Directly you can give it into accumulator.
Okay,
But
ma'am.
if you are giving one number in accumulator, the second number also you have to take in general purpose register. You should not see, there is a way how you can give in the memory location and take, but the program should be something like if you are using general purpose registers, keep it in registers. If you are using memory locations, then you take it in memory location only. That is a educated or cultured way of doing the programming. Half you cannot take here, half you cannot take there. Right?
Okay.
See, I told earlier also, you can have 2-3 ways of writing the program, but you have to see that the final result, what you want, that should be achieved with the instructions which you are trying to write. Now, after saying add M, the machine will give the result in hexadecimal. You have to convert that into decimal. So for that, you have to use DIA instruction. Now, after converting, the machine will do the conversion. You don't bother how it is working. How it is working also is explained, but now we will not go into the details of how that instruction is working. The machine is doing, but only you give the instruction that convert the hexadecimal into a decimal number. Now, whatever is in 8 bits in hexadecimal, it is possible that it may be more than 8 bits when you convert it into decimal number. So, after conversion to decimal number, if it is more than 8 bits, it means there is a carry. It will change the status of your carry flag. So that is why JNC ahead instruction, branching instruction is there. We don't know whether the result is more than 8 bits, but automatically when the machine is doing the execution, the carry flag will change the status. So that is why simply by giving JNC ahead, the program will see that the carry is there or no. If there is no carry, you execute the instruction STA. Means there is no carry, whatever result you are getting in the accumulator, that you move into a memory location 2503H. If there is a carry, then you increment the contents of C register. C register we cleared it and kept, so that if there is a carry, you can increment the C register. See there, you have to give INRC. It is not INX. Note that point there. If you give INR, then it will only increment a single register. If you give INX, means that particular pair, HL, is a pair. So in the architecture or the block diagram of 8085, you will see the general purpose registers BC, DE, HL. These you can use them individually or as a pair. Pair means you cannot take B and L. You have to take BC only. Right?
Yes, ma'am.
Right. So next, if there is a carry, it will you have to increment the contents of C register. If there is no carry, then directly that machine will not execute that increment C. It will directly go to STA, and then after STA, it will say move the contents from C to A. See here, if C is not incremented, it remains 0, 0. If it remains 0, 0 also, there is no problem for you. You can simply say move A comma C, means whatever is there in C, you move to the accumulator and store the contents of accumulator in 2504 position. If there is a carry, only you increment the contents of C. If it is not there, you leave that instruction and go. See, branching instruction, it is JNC ahead. If there is no carry, go to the location where the label is ahead. If there is a carry, then you execute INRC. You have to clearly understand this point. Branching instruction, how it is working. So here two things which you have to remember. In such a situation where the carry is coming, it is better that you use memory locations for your data as well as the result. If you don't want to use memory locations, then you have to, without using that also you can plan to write. But you have to use DAA, you have to use JNC. So how the things are working, it should come like an image in front of you. A register is having this, B register is having this, HL register is having this. So every time an instruction is written, you should know what is present in that, in the background. Then only that flow of the program will come out, or the purpose of getting the result will be solved. So for this, what you do is, these instructions, at least which you are using in the program, you should know how they are working. Then only it will come like an image for you. So this is with your decimal addition. Now, next one is addition of two 16-bit numbers. This is, see here, it is 16-bit numbers. Two 16-bit numbers are being added with the sum 16-bit or more. So just now I said 16 bits can be address or data. So this program will show you about this. It will be a little complicated. Nobody will ask this question. But if you want, I can still tell you this one. Go through the program. Now here see, instead of saying LXI, they have used load HL pair, load HL pair with the contents of 2501H. Now, why it is taken as 2501H is whatever data is there in 2501, it will go to L register, and whatever data you have already stored in 2502, it will go to H register. So your data is in memory location, and from there you are giving the location from where the data will come into H and L register. So first L register will be filled, next H register will be filled. See, if you don't want to give that instruction, you can directly give LXIH and the 16-bit data. So the first 16-bit data is 5B98. So you can still say LXIH 5B98. Means 5B98 will be in HL. But if you are using LHLD, an address location, the data which is there in that address will come into L register. Then 2502 location data will come into H register. Both the instructions are different. They work in a different way. Now, when you say exchange, here also, when you say exchange, it will change the contents of HL and DE. So if you see the block diagram, above HL register will be DE register. So what it will do is, whatever is there in DE, it will put in HL, and whatever is there in HL, it will put in DE. That is what happens when the instruction exchange is executed. Now, you may think, now the data in HL is changed. Yes, it is changed. So for that, again you have to get second number in HL. So second 16-bit number should come in HL. So for that, they are given the instruction LHLD 2503. With this, now the HL will contain the second 16-bit number. See, there is no instruction for loading DE pair directly, which can be done with HL register. Like you are having LHLD, there is nothing like LDED. That instruction doesn't exist. So that is why if you want to push what is there in HL into DE register, you have to give exchange. Exchange will work only with HL and DE. It will not work with HL and BC. This point you have to remember. Now, again you are saying MVI C00 means you are clearing the C register. Then if you have to add two 16-bit numbers, the instruction which you are going to use is DAD. DAD-D. There is, you will also have DAD-H also. If you are saying DAD-H means HL will be added to itself. When you say DAD-D, DE register contents will be added with HL register contents. DAD-D. So next instruction is again jump if no carry to head. So this is same as earlier which we have used. So after the 16-bit addition, if there is a carry, it will check the carry flag. And then if there is a carry, it will increment C. If there is no carry, it has to go to the location where the label is written as ahead. Now, in this case, just as you have said LHLD, that is for loading, to get from memory into register pair. If you say SHL, it will store the result from the general purpose register into memory location. So it will store there. So it will be similar to your STA. SHLD 2505. So how it works again? whatever is there in L register, it will go to 2505, and whatever is there in the H register, it will go to 2506. So it is 16-bit addition. Till now, for 8-bit addition, result was in accumulator. But in this case, after adding contents of DE with contents of HL, the result will be in HL register. So you have to push the contents of HL register into the memory location 2505 and 2506. Now, if there is a carry, you have to move from C register to accumulator and use the instruction STA 2507. That is also possible. So like this, the addition of two 16-bit numbers with a carry, you can write a program. Here we have assumed that a carry is there. If there is no carry, you need not have to use MVIC, 00, and again you need not have to check for the carry also. Since we are not sure whether there is a carry or no, you are using jump if no carry. You are providing a register for the carry. Okay. So this is in a more general way. It is taking that, it is assuming that there is a carry, and it is showing that in the memory location 2507. So 2507, here you are not using INXH. Directly you are giving STA, 2507. If you know any other way how you can push the carry, that also you can do. Now, 8-bit decimal subtraction, they are not asking. So don't go into that complication there. Leave that part. Now, next one is?
Ma'am,
Yes.
memory address we have to write written in the exam, already you said. But one doubt, ma'am. Continuous address is we have to given automatically, easily you have to write. Sometimes see the page number 123, ma'am. 2000 after 2000 we have to write 2003, next to 5.
Yes,
6.
yes. See here.
How can you write?
When
are not
yes, I understood your point. See, when you are doing the practicals, you will press next and you will give 8-bit data. Again, you will press next, you will give another 8-bit data. This is what you have done, right? Are you able to recollect? You recollect what you have done. Every time you are pressing the next tab, next key, and you are giving the data. Now here, the first one is 2000. 2000, it will take 21. Next, 2001, it will take 01.
Yes.
Next, 2002, it will take 25. Now, this instruction is 3-byte instruction, LXIH 2501. So, you have to give 3 locations where it will save. So, that is why the next location is 2003. You are not saying 2001 there. The first instruction is 3 bytes. If the first instruction is only 1 byte, then it will come 2001.
1. Yes, ma'am.
So that is why you should also know the instruction is 1 byte, 2 byte or 3 byte. You have to provide space, no? Otherwise, what it will do, where it will go? It will become junk for the processor. It will not save 01 and 25 if you are not giving place, no?
Yes, ma'am.
Or when you are simply pressing next, what will happen is it will save that 01 in some other location, 25 in some other location, and you will think that you have given it properly. By pressing the next button, what you have done in the lab is automatically without you giving 2001. When you press next, it will take 2001.
Okay, ma'am.
And here, problem when it will come is that label where you are giving ahead label.
Yes,
Ahead
ma'am.
label is for you to understand. Machine will not understand ahead label. See there, when you say JNC ahead, you have given the machine code for JNC as D2, and ahead address location should be mentioned there.
Yes, ma'am.
See there, it is 0D, 20. That is 200D is the address location of where that ahead label is given.
Yes, ma'am.
So you should know whether the instruction is 1 byte or 2 byte, because see, although you are not writing machine codes, but approximately if you are writing the memory address, at which address that JNC ahead will go, you will know that. Or
Yes,
don't bother about all those things. You write ahead because anyway you are not giving machine code. But you should know whether it is 1 byte, 2 byte or 3 byte instructions. What are the different types of instructions? There was a question in the exam. So few students have written data transfer instructions, arithmetic instructions, logical instructions intelligently. There were few students who wrote the instructions as 1 byte instructions, 2 byte instructions, 3 byte instructions. So this answer is also correct. That answer is also correct. What are the different types of instructions? So it is how your perception of the question will be. No, if I am correcting the paper, I will say, no, this only should be the answer. Means that is not like that, no. What are the different types of instructions? In that, you can write data transfer, logical, arithmetic, branching instructions. These are also different types of instructions. As well as the instructions can also be of 1 byte, 2 byte, 3 byte instructions. I am telling you something which I have seen sometimes. Right? So you have to practice all this little bit. Few programs you practice, that will help you to get through the programming part. How you have done all these practicals? What all practicals you have done? Like what all programs you have done in the exam?
Addition, subtraction, one's complement.
Use
And
complement,
then
mask the data.
it's like masking, mask of more significant and less significant.
Smallest,
And
largest.
and this
Like, so these programs only you prepare for your exam also.
Ma'am, memory address we perfectly you have to do not write. Only approximately you have to write. They give full marks now, ma'am.
Yes. I told no memory address. Anything you can write 2000, 3000, 4000, 5000. It should be something in 1000 only. 2500, 2200, 3300, anything. See, only one thing you remember in this: your data and result address locations and your program address locations, there should be some variation. At least put 500 difference in that, or some 100 difference in that. But you cannot write like 2000 you are starting your program address and 2010 you are giving your data, because it is possible that the program may be more than 2010, no? So give some big gap of about 50 locations or 100 locations. Not 50, 100 is more preferable. So if you are taking 2000 as starting address of your program, you can give 2500 as the starting address of your data. See, at the most data means how much it will be? 2 locations. 2500, 2501, 2502, 2503. So like this, you can give data in 2, 3 locations, see the result in another next 2 locations. Like this you can give. And now that masking, also one small program is there. Only one instruction is there which will mask the 4 bits. Generally they are asking mask the either the least significant or the most significant. Page number 131. So in that masking, only one instruction, ANI. ANI F0, it will mask the least significant 4 bits. Whereas ANI 0F will mask the most significant 4 bits. How it works?
Just
Can you-
do AND operation with the immediate data.
Yes. Excellent. So you are doing AND operation with the data. So AND operation only when both the inputs are 1, 1, then the output will be 1. So that is how that ANI instruction is working. So in this, don't confuse whether it is least significant or most significant. So for least significant masking, F0 you are using. For most significant masking, 0F you have to use. If you give 0, it is masked, because whatever be the number and operation, unless it is 1, it will not give you any result. Only if both the inputs are 1, the output will be 1. So with that only the whole program will be over. Now next you go to the branching part. That smallest number and the largest number. It is page number 138. Page number 138. To find smaller of 2 numbers. So see again, this LXIH they have used. The 2 numbers which are chosen as per your material is 84 and 99. And initially here there is some mistake, I think. Move A comma M they have taken in the beginning. Ignore that one particular instruction, or you cut it in your material also. Initially you say LXIH 2501H. So next instruction is move A comma M, means whatever is there in the memory location whose address is in HL pair, means it will take here in the memory location 2501, the data is 84. So it will push that data 84 into accumulator. When you say move A comma M, 84 is going into the accumulator, then you are incrementing H. So it means that HL pair will have 2502. Now after incrementing, you are saying compare M. Means you have to compare the contents of memory location whose address is in HL pair. Now the address in HL pair is 2502. At 2502 location, the data is 99. So now with CMPM, 99 is compared with the contents in accumulator. In accumulator, you are having 84. 84 and 99 you are comparing. So now write in your notebook what I am telling. Accumulator is having 84 and memory location is having 99. So it is here the second number is in memory location. So you are saying CMPM. If you take in a register, that is also possible. But first we will see how to understand this memory location. Now, contents of A. If A is less than M, write in your notebook. If A is less than M, then carry flag is 1 and 0 flag is 0. So you will say carry flag is set and 0 flag is reset if A is less than M.
Again, once repeated, ma'am. A less than M, carry flag is?
Then carry flag is 1 and 0 flag will become 0. Yesterday I told you there is one instruction depending upon which the decision should be taken. So compare, I said yesterday also. If A is less than M, or instead of memory location, it can be a register also. Instead of memory location, it can be register also. So when you give the instruction compare M, the status flags will change. And if A is less than M, then the carry flag will be set. That is what CY is equal to, carry is 1. And the 0 flag will be reset. So 0 flag will become 0, carry flag will become 1. Now, if A is greater than, if next point you write, if A is greater than M, both the flags are 0. Carry and 0, both the flags are 0. So remember only one. If A is less than M, carry flag is 1, 0 flag is 0. If A is equal to M, if A is equal to M, then carry flag is 0 and 0 flag is 1. So these are the three conditions. In this, you remember only one. The first one you remember. If you try to remember all the three, you will get confused. So remember only one. So let us assume that A is less than M, carry flag is 1 and 0 flag is 0. So now come to the next instruction in that program. It is JC ahead. Jump on carry to the location ahead. Now I said we as per our data, A is less than M. So what will happen? The carry flag will become 1 and 0 flag is 0. And we have given a branching instruction, jump on carry to ahead. The program is to choose the smaller of two numbers. So since our smaller number is now in accumulator, at ahead label, I can give an instruction STA, store whatever the contents of accumulator in the location 2503H. So luckily our data which we have chosen is such that A is less than M. Because we are giving the data, we know. But if there are more than two numbers, then what will happen, that we will see later. Now, and luckily in this, accumulator number is less than memory location. If it is not less, then what it is to do? Then there the instruction is missing. If it is not less, then you have to move the contents from the memory location to accumulator. That one instruction is missing. See there, if the condition is satisfied, jump on carry, it should go to ahead. If the condition is not satisfied, that means the smaller number is in memory, then you have to move from memory into accumulator, and then you have to say STA 2505. Write there and keep in your material after JC ahead that instruction, move A comma M, which went into the heading in the table, that has to come before STA. I hope you followed.
And they gave.
It is there in your material. Okay. Then no problem. So always, whether you are trying to look at the smaller number or the larger number, you should see that accumulator will contain the result. And then from accumulator, you have to push to the memory location. Now, smaller number, this is the program. For larger number, instead of using JC, you can simply use JNC. Jump if no carry. No carry means the larger number is
In accumulator.
in accumulator. Larger number is in accumulator. So if you are seeing smaller number in accumulator, use jump on carry. If you are seeing larger number in accumulator, use jump on no carry. Because you wrote the condition there, if A is less than M, carry is 1. If A is greater than M, carry is 0. Now, the trick is in this only. Now, if you have to take now we will see largest number in the data array, that is page 142. So there are 3 numbers. Are you seeing?
Yes, ma'am.
There are 3 numbers, 98, 75, 99. These are the 3 numbers. And from these 3 numbers, you have to choose the largest number. So when there are like this 3 numbers or 5 numbers, you have to give a counter, one counter register. Did we discuss that addition of 3 8-bit numbers?
No.
I missed it, I think.
The sum of array was.
Okay, this one you see, so that also you can understand. Now the flow chart is given in your 143 page itself for the largest number. First you understand the program, then you can see the flow chart. You have to find the largest among the 3 numbers. So since there are only 3 numbers, here you will have one register where you will put that count of 3 numbers. If there are 5 numbers, then you have in the register you have to put that counter as 5 numbers. Now go through the program, and as you see the program, you will understand. In this also, largest of 2 numbers, we have used JNC ahead. Same JNC ahead only you have to use. Means the logic by which you are trying to choose the largest number is depending upon JNC ahead instruction only. But for 2 numbers, number of instructions were less. When it is coming to 3 numbers, larger of 3 numbers, then the number of instructions will change because you are having a counter. So initially the counter will be 3. Then after comparing 2 numbers, you have to decrement it to 2. Again, after comparing the resultant and the third number, the counter will become 1. Like this, the counter will go on decrementing, and at one point when it becomes 0, it means you have compared all the numbers. So A, B, C, 3 numbers are there. The trick is like this in this. Let us assume you are having A, B, and C, 3 numbers. So first you will try to choose the largest of A and B and put the larger number in accumulator. Now that larger number and C, you have to compare these two. And among these two, which is larger, you have to put in the accumulator. Now choice of the larger number will be decided by the instruction JNC ahead. So you have to keep track of the counter as well as the larger number. These two things, how it works in the program, let us see. Counter also they have given in one memory location, like how many numbers you are going to compare. If you are not giving in a memory location, directly you can load the counter in a register. So LXIH 2500, in that 2500 location, the counter 03 is saved. Then afterwards, that counter number is saved in C register. Move C, M means it will saying the counter in C register. You can use B also, you can use D or E also. So don't use HL, because HL you have retained to put the address location. So don't use HL. Other than that, you can use either B or C or D or E, individual registers. So we have in this program, it is C only. Now next, you are incrementing H. If you increment H, then 2500 will become 2501 after incrementing that H. Then you are moving the contents of memory location into accumulator. Means we have got the first number or the first data in the accumulator. Now our first data is 98. 98 has come in the accumulator. Then afterwards, decrement C. So out of the three numbers, one number you have taken. So you are decrementing C. So from 3, it will become 2 now. Now afterwards, you are saying again increment H. Means now the H value will be, HL register pair will contain 2502. After that, instruction is compare M. Means whatever is there in 2502, 75 is compared with 98. Jump if no carry to ahead. So since our accumulator is larger, because we are seeing the data, we are able to tell this. It will go to the location ahead. If the accumulator is not larger, then it will move that larger number which was there in the memory location 2502, it will move into the accumulator, right? If the larger number is in accumulator, that will be decided by the instruction JNC. If there is no carry, then it will go to decrement C. Now C which was 2, it will become 1. After it becomes 1, if the larger number is in accumulator and if the counter, since now C is 1, it is not 0. Jump if not 0 to loop. It has to go back because one more number comparison is still left. If C value is 0, then it will directly push the larger number from accumulator into the address location 2450. Now, if the memory content is larger, it will push in the accumulator. There are two ways. JNC has to take a decision here, whether the larger number is in accumulator or it is in the memory location. Now, if it is in the memory location, it has to push to the accumulator. Two numbers are already compared. Now, next it will say decrement C. Then now your C will become, from 2 it will become 1. Next, since C is not 0, it will go back again to execute a loop. Once again, it will say increment H. Now H value will be 2503. After saying increment, now it will compare 99 with the larger number in the accumulator. Again, it will check whether the larger number is in accumulator or no, and that will be done by the instruction JNC ahead. Now again, the process like this continues. Once it will see that the C register has become 0, it will come out of JNZ loop and it will push the largest number which we obtained in the program in the accumulator to the memory location. So there are two branching instructions here. One is for comparison. Another is whether all the numbers are compared or no.
Ma'am, this DCRC 2 times is given.
Here it has used 2 times because there are 3 numbers they have taken 2 times. If you can include that DRC somewhere like a loop, then also it is possible. So 2 Once it is comparing first number and second number, from those two which is largest, that number is compared with the third number. So that is why DRC is used 2 times.
Okay, ma'am. Because when we did practical, we used only one time with a loop.
Yes, that also is correct. You can do that also. That also is correct. You can use that also. But put that instruction inside a loop. Then every time the loop is number of iterations will make that equal to 0. See the next program. In that they have used DRC only once. That is alternative program they have given there to find the largest number.
Yes, ma'am.
They have used that inside a loop so that loop will reduce the number of instructions. And then from the largest and the smallest number, you can see there is only one instruction. Here it is JNC, there you will see JC. Otherwise everything will be same.
Same.
Yes. Here also they have given alternate program where a DRC is used within the loop.
Okay.
So for the same purpose, you can have different ways of giving the instruction, but you should understand how the instruction works. Then it will be easy for you. So here there is a message like 8253 and 8255 pin diagrams. Pin diagrams. It is in the interfacing devices, I think.
Yes, ma'am.
No, it is programmable peripheral interface 8255.
It is after 8085.
Yes, I saw. Eight two five three is see, first thing is the peripheral devices means these ICs are used as a what we say mediator between the processor and the output devices. So sometimes if you want many other functions to take place, then like you want to connect a printer, you want to connect a fax machine, like this, if the output devices are more, then your 8085 cannot support all these output devices. So to support so many different output ports, you can call them as devices or ports, you need an intermediate or a mediator there. A mediator IC will solve this purpose. So in that context, this 8255 and 8253 are used. This point I think I have explained in the class. We have referred to these ICs also. Same is the case with your 8253 also. And there for your 8253 IC, you will see counter 0, counter 1, counter 2. Each will have their own independent pins for which they can be connected. So in that you are seeing that clock 0, gate 0 and output 0. And similarly for the others, you will have their own specific pins for which you have to connect. So that is why you are seeing there clock 0, clock 1, clock 2, and respectively gate 0 and output 0. So I think now we cannot discuss so much about this. I'll see if I can trace out some of my notes of 8253. I will put it on the WhatsApp group.
Okay.
That I will see. I will see, and then I will. If it is existing, then I will put on the group for 8253 and 8255. You can read those things, and that much you can attempt for your exam also. So I'm stopping now because I think the next class, madam will be waiting for the class. So if there are very specific doubts, then you can put on the group. I will respond to that.
Okay.
Okay. Okay then. Thank you all. I
Thank
hope whatever I have taught will be of use to you.
Yes, ma'am. Sure.
So if you are having something very see, try to solve within your group. If it is not solved, then I'll respond to the questions which you are putting on the group. Right? Thank you and all the best. So I'm leaving
you,
now.
ma'am.
Right?
Thank you, ma'am.
Right.
Thank you, ma'am.
Okay.
Chanchal, are you prepared? Chanchal?
Yes, preparing.
What about remaining 2 subjects?
Not started.
Okay. Thank you.
Ma'am
Ma'am,
left. Actually, she told she'll give 80486. No, she'll not give today.
80, which one? 46. 486.
80486. Yes.
Ma'am told yesterday this was very lengthy, so no need to read this one. She told.
Okay.
It will get confused. Which blocks are finished, Chanchal?
I have not finished. Just read.
Okay. 8085?
Yeah, means
8255 you read.
I read.
The subject is related to no? This one and Sangeeta ma'am subject?
It's not related. You just I know.
Okay.
The theory and practicals are totally different. What we are using in office is totally different. That are very advanced version. This is basic only in book.
In practical also different, no?
Yeah.
In the book also something is different. Don't know how to write, how to prepare. This was very lengthy.
Okay, we'll try.
Okay,
Okay.
bye. I'm also leaving.